Welcome to today's presentation titled Intelligent Motion Control, Accelerating Digital Transformation in Smart Manufacturing. My name is Maurice O'Brien. I'm the Strategic Marketing Manager, part of Analog Devices Industrial Automation Business Unit, based out of Limerick in Ireland. For today's agenda, first of all, we will discuss digital transformation in smart manufacturing, followed by a discussion around intelligent motion control and how it is accelerating digital transformation. We will discuss key technologies to accelerate digital transformation, followed finally by a summary. Digital transformation in smart manufacturing promises considerable value and benefits. Global spending on digital transformation is estimated to be $6.8 trillion by 2023. Digital transformation promises exponential improvements in productivity, efficiency, and safety, driven by advances in edge-to-cloud computing, leveraging powerful analytics to enable more flexible, scalable, and ultimately more sustainable smart manufacturing. At the heart of digital transformation is data. As we increase the amount of data that's being generated, we have to deploy enhanced connectivity solutions if we are to deliver the promise of digital transformation. So smart manufacturing fueled by digital transformation is really centered on generating more data and using advanced analytics to create insights from this data with a view to increasing productivity, flexibility, and ultimately more sustainable smart manufacturing. One of the key challenges around connectivity is how do we bridge the IT, the information technology network, and the OT, the operating technology network. If we are to make the data that resides at the edge of our networks in terms of the connectivity to sensors, actuators, motion applications, including robotics, we need to make the data within these end assets more accessible. We need to get this data to the cloud, whereby we can deploy the advanced analytics to create the insights that ultimately will drive the increased productivity of our smart manufacturing. So we have to bridge the IT and the OT. Seamless connectivity is the key. Again, to unlock the promise of digital transformation, we need to enable our applications across factory automation and process automation to be able to share data from the end node through to the field, up to the control level, and ultimately into the enterprise. We have to bridge the IT and the OT, and we will do that with seamless industrial Ethernet connectivity. Intelligent motion control is the core building block of smart manufacturing. Digital transformation in smart manufacturing can drive productivity improvements, enable more flexibility and scalability in terms of the manufacturing footprint, and finally can deliver more sustainable smart manufacturing. Motion control has evolved over time. Grid-connected motors are the most basic and simple motors used in smart manufacturing today. They run at a relatively fixed speed, independent of any load variation. Therefore, they are a relatively inefficient solution. In order to drive higher levels of efficiency in smart manufacturing, we see an accelerated transition towards inverter-driven motors, where the addition of an inverter stage now allows the motor to run at a variable speed, and the speed of the motor can now be matched to the load requirement, which enables significant energy savings. To enable higher levels of automation in terms of performance and complexity, a variable speed drive adds both current and position feedback to the inverter-driven motor to provide more control in terms of speed, velocity, and torque. Building on the variable speed drive is a servo-driven system that has multiple axes that are synchronized to provide high quality motion control. So for example, in machine tools and CNCs. Building on top of the servo-driven system is mechanical integration and machine control used to deploy industrial robot solutions. Collaborative robots build on top of industrial robots by adding safety sensing, such that an operator can safely work in close proximity to the collaborative robot. And then finally, mobile robots build on collaborative robots by adding localization sensing and collision avoidance. So here with this slide, we see how intelligent motion control has evolved over time to deliver higher levels of productivity, efficiency, and ultimately autonomy in smart manufacturing. Digital transformation in smart manufacturing is really being accelerated by three key growth drivers. First of all, is a desire to reduce energy consumption in smart manufacturing. Secondly, is a requirement for more agile production that can quickly change based on customer demand and end market dynamics. And finally, a move towards new business models around service-based activities. So we will look at each of these three key growth drivers in a little bit more detail in the next few slides. Let's first of all look at sustainability and our goal of reduced energy consumption. One of the key enablers of reducing energy consumption in smart manufacturing is accelerating the transition from fixed speed motors to variable speed motors. Given that almost 70% of electricity consumed by industry is used by electric motor systems, there is a huge opportunity here in terms of variable speed drives. Regulations are actually playing a really important part of this transition, and recent EU regulations that came into effect in July of this year, 2021, have further strengthened and are accelerating that transition towards higher efficiency motors, higher efficiency drive solutions, and also higher efficiency motor with integrated drive solutions. So for example, in the case of a motor, we have 5 different classes of efficiency ratings, and with a goal to try and move from the IE1 towards the higher levels of IE2, IE3, 4, and ultimately to IE5. And equally, we have similar efficiency standards for both the drive and the motor plus drive. If we are to deliver agile production, which gives us more flexibility and productivity, connectivity will be a key part of delivering this going forward. So I'm going to look at 3 areas briefly in terms of industrial Ethernet, in terms of the potential for 5G within smart manufacturing, and finally we will briefly look at IO-Link. So let's kick off with IO-Link. As we look to make our smart manufacturing installations more intelligent, we need to be able to support more intelligent sensors and actuators. IO-Link is a digital point-to-point communication that enables edge devices like sensors, RFID readers, valves, motor starters, and I/O modules to be installed and configured quickly. IO-Link supports self-diagnostics in terms of the health of the asset, and ultimately enable new devices to be installed and replaced very quickly and easily, again with a view to delivering more flexible and scalable manufacturing. Industrial Ethernet enabling deterministic motion solutions in smart manufacturing. Today's smart manufacturing utilizes 100 megabit industrial Ethernet connectivity combined with layer 2 industrial Ethernet protocols like EtherCAT, Profinet, Profinet IRT, Ethernet IP as examples. Real-time deterministic industrial Ethernet is used to control complex motion, for example with industrial robotics or in conveyor pulley systems. But we see a transition towards gigabit connectivity as we increase the complexity of the automation and we look to deploy alongside the deterministic motion solutions, increased amounts of vision systems that monitor for quality and ensure safety, we see a requirement for more data bandwidth to be supported in our next generation of smart manufacturing capabilities. So we see the deployment of gigabit TSN, which supports both cyclic communication for motion control and acyclic or non-time critical communication in terms of vision systems and health monitoring of assets. Finally, in terms of connectivity and smart manufacturing, let's discuss the potential of 5G in next generation smart manufacturing. Traditionally, wireless connectivity was used for more of the monitoring communications in smart manufacturing, and wired connectivity dominated in terms of control. And really that was because traditionally a lot of the wireless capabilities were unable to deliver the levels of latency, determinism, and reliability to be used in control applications. However, 5G has the potential to make a positive disruption in terms of smart manufacturing connectivity. And this is driven by 5G's capability to be able to support ultra high reliability and ultra low latency, which now opens up 5G as a potential for communication to be used, for example, with mobile robots and industrial robots in smart manufacturing. Finally, in terms of new growth drivers, new business model opportunities are being created around condition monitoring. So typical asset examples within a smart manufacturing environment include automation equipment, pumps, and conveyors. So one of the key goals of digital transformation is to reduce unplanned downtime, followed by extending machinery lifetime. If we can extend the usable lifetime of an asset, then we can have an important sustainability impact by reducing the amount of raw materials and energy to build replacement assets. Condition monitoring can drive higher levels of uptime and productivity. And then finally, there is the opportunity for increased billable hours for service-based contracts. Let's take a moment to look at two examples of service-based contracts that are being enabled via condition monitoring and digital transformation. So the first one revolves around pumps. Today, a pump OEM sells a pump and installs a pump. They have an ambition to create new revenue-based streams based on providing services. And rather than just selling a pump, they want to charge their users based on the volume of liquid pumped, be it water or fuel, thereby creating new service-based revenue streams. A second example is around conveyor systems. System integrators today are installing and maintaining very complex conveyor systems, for example, in parcel sorting warehouse applications. Again, their ambition is to provide more than just that installation service. They want to charge based on the number of parcels sorted. They want to charge based on providing a service and delivering a certain level of uptime. So both the pump in terms of providing water and the conveyor belt opportunity in providing uptime and charging based on the number of parcels sorted are two really good examples of how digital transformation, in this case via condition monitoring, is creating new revenue stream opportunities. Intelligent motion control plays a key part of enabling digital transformation in smart manufacturing. Intelligent motion control requirements include superior motion control, robustness, safety and reliability, real-time connectivity, combined with advanced sensing. By delivering on these four requirements, we enable next-generation smart manufacturing that is more productive, that is more flexible and scalable, and delivers more sustainable smart manufacturing. In order to meet the requirements just outlined, there are 6 key technologies that need to be deployed to meet the requirements for intelligent motion control. First of all is precision measurement. Intelligent motion control requires precision current, voltage, and position sensing with a view to delivering higher levels of quality and actually to have more optimized manufacturing, whereby we can reduce the manufacturing time and the manufacturing steps within a manufacturing flow. We need isolation and interface technology to ensure robust, reliable operation and to ensure that we have a safe environment in which our operators interact with these assets and that we provide safety isolation around the various assets within smart manufacturing. We need robust and reliable power management solutions. We need higher density power management solutions such that we can have smaller form factor assets that can be decentralized and moved closer to the manufacturing asset themselves. So, for example, in order to enable more higher levels of flexibility and scalability in intelligent motion control applications, we see a transition from centralized drive racks to more decentralized drives that are placed closer to the load, and in some cases we see the drive being integrated with the motor. And in order to implement and meet the requirements for more decentralized drives, we need to be able to have smaller form factor drive enclosures, and high ambient, robust power management solutions will be a key part and a key enabler for this. We also need industrial Ethernet solutions that are robust, that scale up to gigabit speeds, that provide real-time connectivity in terms of layer 2 protocols, be it EtherCAT, Profinet, Ethernet IP, and going forward, supporting time-sensitive networking, 802.1 standards, to ensure that the data that we generate in all of our various motion assets can be seamlessly accessed, and that we can bridge that IT/OT network to make the data more accessible to the management layers. In order to meet the requirements around accurate and robust position sensing, magnetic sensing provides a lower cost and more robust solution to optical solutions today. And then finally, machine health will provide a means of ensuring that the asset operates within the manufacturer specification, such that we optimize maintenance schedules, we eliminate unplanned downtime, and we provide a safe environment for our employees within smart manufacturing by ensuring that our assets are operating within the manufacturer specification. And then finally, even from a quality perspective, we can improve the quality of the manufacturing, again by ensuring through machine health and condition monitoring insights, again, that our assets are operating within the manufacturer specification. The combination of Maxim integrated, now a part of analog devices, and Trinamic, now a part of analog devices, enables ADI to provide a broader base of technologies for intelligent motion control applications to help our customers and partners accelerate their digital transformation journey. In summary, digital transformation in smart manufacturing enabled by intelligent motion control solutions will have 2 key benefits. First is reduced energy consumption. Intelligent motion control applications built with variable speed drives will significantly reduce energy consumption in smart manufacturing. Secondly, agile production enabled by intelligent motion control will provide smart manufacturing that is able to quickly react to changing consumer demand. As we see post-COVID lockdown increases in consumer demand, The need to future-proof our smart manufacturing has never been clearer. Intelligent motion control, leveraging digital transformation, can provide next-generation smart manufacturing that can quickly react to changes in in-market demand and consumer buyer behavior. I hope this presentation was informative. Please reach out to me via LinkedIn or via my email if you'd like to discuss further. Thank you.